Hey, welcome. This is quantum mechanics in 5 minutes or less. This is the definition. Quantum mechanics, the branch of mechanics that deals with the mathematical description of the motion and interaction of subatomic particles, incorporating the concepts of quantization of energy, wave-particle duality, the uncertainty principle, and the correspondence principle. To put that simply, quantum mechanics is the study of physics of atomic and subatomic particles, for example, Schrödinger's cat, where you have a cat in a closed box near a device that has a 50% chance of the cat dying and 50% chance of it living. In 1 hour, you come back to open the box. You would not think much of this funny situation until you bring quantum mechanics into it. The rules of quantum mechanics proves that the instance before you open the box, the cat is both 50% dead and 50% alive. It is when the box is open that it is decided whether or not the cat is dead. This is proved by how everything is made of waves. Superposition, which is the state of being in multiple places at the same time. Think of it like this example. You take a singular light photon in which you shoot it through two holes in which they will land on a wall behind on the other side. After you repeat this for a while and track all the landing spots of each trial, you will notice that the number of photons in each spot resembles a wave, just like this image right here. This proves superposition must be true because that's how actual water waves work too. Think of it like this. You splash and make a wave. It goes out in this direction. If you watch the water waves through two rectangular holes pointing out of the ground, you will notice that the most water lands in the middle where the two crests meet, and the least water will land where all the troughs meet. The two crests meet at farther away points as well, and that's when a wavelength will start getting lower and decreasing. So editor Liam here to explain this a little bit better. The top is a wavelength, right? And you're shooting the electrons through two holes, right? And you can see on both sides how it gets dimmer and stuff. That represents the wavelength. The wavelength's like down going, like there's a peak and then the down parts. That's what that represents. The more the water waves have to travel, the smaller the crest hits will be, and therefore smaller amount of water splashes up. This is exactly true in the quantum realm too. For the more photon has to travel, the less photons end up hitting the spot. To confuse you even more, with the rule of quantum mechanics, you'll never be able to see the particles in the multiple positions, because like I said earlier, as soon as you make the action of seeing the cat, like the particles, they'll stop moving. They'll make a decision up. Therefore, you can't see the same particle in two positions, okay? Two or more. You still don't believe me? Just think of it like this. With no superposition means no wave. With no wave means no cat. With no cat means no anything. With no anything means no you, and therefore you wouldn't be here right now. I rest my case. And there you go. That's quantum mechanics in less than 5 minutes.